Failed December 2020, aircraft model GP500, aircraft serial number 0001, flight number AZ101, origin airport or departure airport ABC, destination on arrival airport ZYZ, scheduled departure 1 o'clock in the morning, scheduled arrival 4 o'clock in the morning. So it's as per our model, right? Example. Actual departure 4 o'clock in the morning, actual arrival 7 o'clock in the morning. Mission interruption ground. D means delay, C means cancellation. Mission interruption flight not applicable because we said, let's say during flight everything was okay. Problem report. After engine 1 start, AC generator failed to connect. Corrective action. Engine 1 AC generator replaced. Test okay. Removed part number 123-4, serial number 234, installed part number 123-4, serial number 678. Problem initiator P here means pilot and M means mechanic, ATA 24010203. Now, as I mentioned in the very beginning, this is minimum data, right? So if we need, if our experience tells that hey, we need more, or government says hey, we need more information, definitely we are collecting more information. Now, how we are using all this collected information, what we are doing with this collected information, to answer this question, let's go to the next slide and see our reliability program process high-level flow chart. In the middle, what we said, we have aircraft. Aircraft is available or aircraft is not available. And this availability definitely is covered with safety. Safety is always number one. Safety is always first. And it is supported with reliability. Let's say this. Let's take example in 1250 point, right? So we're collecting information. We call it data collection. Then what we are doing with this collected data, we need to process it, data processing, right? We need to cleanse it, we need to code it, we need to filter it, we need to add some intelligence, etc., etc. Then we have to display, we have to report it. It can be Word format, tabular format, graphical format, etc., etc. Then we need to analyze it. Then we need to interpret and give some recommendations. Let's say last 18 months our reliability program tells that we have part number XXX-1 and scheduled removal is, I don't know, let's use 1000 flight hours, okay? Anyway, this is an example. Now, a DSB engineer comes and says, guys, you know what? As per manufacturer documents, as per supplier documents, if we install Dash 2, the reliability will be 3000 flight hours. Okay? 3000 flight hours. Now what we are doing, we are taking this information and going to the, presenting this to the Airline Reliability Board. Let's say Airline Reliability Board says, yeah, okay, you know what, let's remove the part Dash 1 and install Dash 2. Corrective action. Okay? Now, what do you think? Is it enough for our program? Unfortunately, no. Why? Because sometimes you can see Dash 2 is even worse in real life than Dash 1. You can see here 800 flight hours. Follow up. Okay, we again measuring our product performance, and it starts over and over again. Data collection, etc., etc., etc. Now I'm going to give you one more example since we are in under operation ground maintenance state conditions, right? I'm going to give you the example of maintenance tasks, okay, just for better understanding. Let's move to the next slide. So what we have in this business, we have actually two parts. One part is manufacturer, another part is operator. We have, safety. Safety in the airworthiness is always on the top, okay? This, we have to, all procedures, all processes, all analysis should go through safety and airworthiness requirements, okay? Here's maintenance task on operator side. Now, quick question for you. What do you think? Where these tasks are coming from? Answer is from manufacturer side and group called the Maintenance Review Board Working Group. So MRB working group takes MSI, which is Maintenance Significant Item, which is based on product design, ATA system, subsystem, etc., 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 etc. So take this MSI and applies MSG3 logic, Maintenance Steering Group 3 logic, Maintenance Steering Group analysis to determine maintenance tasks and interval. Let's, for our example, use DC battery. So let's define, hey, do you know what, 8824, whatever, 010001, DC battery requires overhaul every 3000 flight hours. So we have to remove it from aircraft when it reaches 3000 flight hours, and we have to send it to the shop for overhaul. Okay? Now, when task and interval is defined, this information goes to the MRBR document, Maintenance Review Board Report. From MRBR, it goes to the MPD, Maintenance Planning Document. Maintenance Planning Document is very interesting document. You can see items, tasks, and requirements from different sources, from safety information, from airworthiness limitation items, from aircraft economies groups, etc., etc. By the way, MRBR document is approved document, MPD is not approved document. Now, when all these documents are approved, manufacturer sends this information to the operator. As I said, we're gonna use DC battery, right? So information is DC battery, shop visit, 3000 flight hours. What operator is doing? Operator is developing approved maintenance program. And they are saying that DC battery, shop visit is 3000 flight hours. Now, planning department that tracks all batteries. Let's say we have 20 batteries in service. Tracks all these batteries, and when battery reaches 2,900 or 2,950 or maybe 3,000, right? Sends task cards or job cards to maintenance department, and maintenance, they are removing old battery and they are installing new battery. Okay, and they are signing paper that aircraft is airworthy and safe, definitely, and the aircraft is ready to fly or aircraft is flying. I'm going to explain now here two scenarios, minimum two scenarios from reliability program perspective. Okay, let's say we have in service 20 batteries. Okay, and we open our reliability program, scenario number one, okay? We open our reliability program and we see the last 8 months we have 20 removals, and all 20 removals are during scheduled maintenance, which is 3000 flight hours, which is as per our manufacturer requirement. So everything is okay. I think airline managers would love this type of scenario. Okay, now scenario number two, we opened again our reliability program, and what we see, we have 5 removals during scheduled maintenance, which is 3000 flight hours. Unscheduled removals, we have 15, the 8 caused delays. Not only this, average unscheduled removal is 2000 flight hours. So manufacturer tells us 3000, our operation tells us, real life tells us 2000. Again, what we are doing, we are taking this information and presenting it to the reliability board, the Airline Reliability Board. The board says, the reliability board says, okay, do you know what, let's delete from maintenance program these 3000 flight hours and add here battery shop visit 2000 flight hours. So now we are replacing these batteries, old batteries, not at 3,000, with the interval of 3,000, no, but with 2,000 flight hours. Definitely, this information goes to the manufacturer, but we are not going to discuss now manufacturer's problem, okay? That's how it works from maintenance tasks perspective and then reliability program perspective. Now, I think we can move now slowly to the flight, and we need to answer questions. Okay, what about flight, and then flight from reliability program and safety program perspective. Okay, and to answer this question, let's move to the next slide. And before we identify or before define this connection point between flight and reliability program, I would like to give you a definition when flight starts and when flight ends. I'm gonna give you here classical definition. Okay, you can say, hey, you know what? In our company we are doing different way, which is okay. You can have another experience, or maybe your government requires another conditions, right? Which is okay. But I'm gonna give you here classical definitions. Now, before we start, I'm gonna read this phase of flight notes here. Presented phase of flight segments are only for reference. Main reason is in general to understand how phase of flight segments are connected to the reliability program and safety program. In real life, there are more subsegments under each phase of flight segment. Okay? Now what we have? We have two airports here, origin airport or departure airport, and destination or arrival airport. Okay? Flight starts. All aircraft doors closed, emergency escape slides in arm position. So doors are closed. Definitely passengers are on the board and pilots. Okay? Wheel chocks removed. Wheel chocks here removed. All engines are operating. Engines are on. Parking brake release off. Aircraft start taxi out from designated parking area to runway. Okay, here is our parking area, this line, and that's where we start our flight. Now, where flight ends, probably somewhere here. Aircraft taxi in and stop within designated parking area, probably somewhere here, right? Parking brake is on. All engines are shut down, it's off. Wheel chocks installed. And here is big warning. Emergency escape slide in disarm position. Door is open. Make sure, it's the warning here, make sure before you open door that emergency escape slide is in disarm position. Otherwise, you will have big problem and your company also will have huge problem. Okay? Now let's start our phase of flight discussion. Okay, let's say everything was okay. Mechanic science release to service. We call this part taxi out. Next part is take off. Next part is climb. Next part is cruise. Next part is actually we have here two parts. Both are important for us for reliability and safety. Descent and approach. Next part is landing, and next part is taxi in. Okay, now let's move to the next slide and define our mission interruption flight group items. Okay, I'm gonna use for mission interruption groups this slide as a summary slide, so I also brought here mission interruption ground group. Just to remind you, we have three items under a mission interruption: ground, delay, cancellation, AOG. Okay, let's say everything was okay here. This is our aircraft, passengers are on board, so no delay, no cancellation, no AOG. Mechanic science release to service. So we're starting moving to the runway, and something happened here. That's the engine problem. Pilot opens documents, and pilot says, no, do you know what? I'm going to return to gate. We call it ground turn back. Now, sometimes I'm just using general terminology here. In the whole, by the way, in the whole presentation, I'm using general terminology, okay?